So hello, my name is Jan Peter. I'm working for Ericsson as a solution architect responsible mainly for packet core. I'm sitting in Prague in Czech, and I will present Norway defense slice together with Antonios. I will start with the requirements defined by Telenor, and the solution description itself will be divided into two parts. I will describe the VNF perspective, and Antonio will continue with the NFVI and the MANO. I've selected 5 main requirements defined by Nokia. We have taken into account when we were designing the VNF topology. From the service perspective, the defense slice should provide the vertical and the broadband access. It needs to be deployed on 2 sites because we need to have a geo-redundant deployment for high availability. Those 2 sites we call the central site and the edge site. Each site needs to handle the user plane, and the central side the control plane. For this, we need to deploy the caps. Do you still hear me fine?
Yes.
For this, we need to deploy the caps control and user plane separation, or based on these requirements, we decided to deploy the caps, and with having caps, we also ensure the low latency for those applications. They don't need connectivity to the internet because the edge site handling the user plane will be deployed or sitting very close to the end user. From the security perspective, what is specific for this slice is that VNFs needs to be isolated, or this slice will be isolated from the others. Because the defense slice is not the only slice deployed on the Norway facility, and some slice shares VNF, and this is not achieved for the defense, as all VNF will be strictly dedicated to the defense slice. Another requirement is having or providing multi-edge support. This is about having more than one edge site connected to the central site. Central site again will handle the control plane and also will work or providing a backup to any edge site. The throughput, or in general the capacity of the central site shouldn't be bigger than the capacity of the largest edge site, because expectation is that this central site as a backup solution would be enough if it would provide a backup only for one edge site. So the capacity doesn't need to be 3 times bigger or covering all edge sites capacity. Yeah, so this is for the requirements and how the solution looks like. So we are going to have 2 sites for the defense slide, the core one and the edge one, with those VNFs here. 5G EPC on both location, same IMS on both location. What else is being deployed or we plan to deploy are another 2 NSA slices sharing some VNFs and providing or supporting enhanced mobile broadband use cases. And we also plan to deploy another 2 standalone slices for specifically for 5G standalone use cases. So in Norway, there will be different slices supporting different users and different use cases. Now back to the defense slice again. So more details here. Defense slice will be deployed as a multi-vendor environment where Ericsson, Nokia, and Metaswitch were involved. Ericsson is a provider of the 5G RAN, supporting standalone and non-standalone solution. And also Ericsson is providing 5G PC and some other VNFs or some other application like subscriber database, PCRF, or VNFM. Nokia is providing end-to-end service orchestration and application delivered by Nokia. It's a service orchestrator, NFVO, or second VNFM. Nokia is also providing the hardware or NFVI solution on both sides. And the meta switch here is a vendor of IMS. We are going to have the two VNFM. The specific VNFM for Ericsson will be used for instantiation of Ericsson application, and the second generic VNFM provided by the Nokia will be used for instantiation of Metaswitch VNFs. One of the requirements was that each site should handle the user plane and the rest of traffic should be pushed to the central site, and how this can be or will be achieved. On MME, there is a parameter called relative MME capacity. This is configured on MME, and when E node B or G node B is connected to MME, all MMEs will provide this information to G node B. And based on this, G node B will decide what portion of traffic will be sent to what MME. In one of these parameters is configured with a 0, and the last with some numbers means that all traffic from that G node B will be sent towards MME3 in this case. Green VNFs here are active VNFs. The yellow ones will work as a backup. So you can see that on central site, those VNFs will handle the control plane, and the yellow one on the edge side will work as a backup. And the active VNF on the edge side, like this S gateway 6 user plane, and those IMS VNF will handle the user plane. And back to this node selection. So when those two MMEs will inform G node B about the relative MME capacity, G node B will send all traffic to MME3. MME3 here also connected to both VNFs, means to HSS2 on central side and HSS3 on the edge side. And based on the link priority, we'll select HSS2. HSS2 needs to go to the subscriber database, and again, based on the LDAP link priority, the UTR1 will be selected. This scenario, when proper VNF is selected based on the link priority, is applied also for selecting S gateway, P gateway control plane, PCRF, or also selecting the S gateway, P gateway user plane. When the proper S gateway, P gateway user plane is selected, the IP address of this user plane gateway is providing to the G node B, and then the terminal can create a session when the user plane will go to the edge site to S gateway 6, handling the user plane, and the rest of the signaling will be handled by the central site.
So Jano presented from Ericsson side how the slices will be deployed, what applications will be per slice, and what is the resilience that we require. Now we're going to see it from the NFVI side first, and then we will see from Mano how we can orchestrate this. But we already discussed most of the details in the previous presentation. So let's see first the architecture from the HCNV. So we see here that we have two NFVI layers, two VIMs. So the first is the central side, where it's everything from Nokia, but there it's with SDN solution. So we have the NUADs, and the hardware is based on the airframe Open Rack. And then the hypervisor and the virtualization layer is based on the OpenStack, and we use the NCIR 18. At the edge side, we use the Z9100 switch. So this is a solution without an SDN, but we use a physical switch there. And we use the OpenEdge 19. We will see more details about the OpenEdge 19 later, because we need less footprint there. So we need to find a more compact solution. And again, there the VIM and then the hypervisor is based on the NCIR. On the Mano layer, we will have the two VNFMs from Ericsson and CBAM still apply for the defense slice. And then we have the flow one, but all of them will be deployed in the core side. We have already there used it for all the other slices that we saw so far. We are not going to deploy new instances at the edge, because we want to keep the edge side as minimal as we can. So we don't want to deploy more components for the management, but just focus on the service and especially on the user plane. So the same components that we had in the central side, we will manage the edge side. So let me also here highlight that what is the risk with this solution is that if the connectivity between the edge and the central side goes down, then the edge side components will not be able to manage by the mano. For example, cannot have scaling, or maybe you cannot have a healing. But this is about management. What is more important is to have the service up and running. And this is what we achieve with the autonomous edge, because all the components, even the smallest scale, can work only with the edge. For healing, for example, are the things we can still connect there, if possible, directly to that VM and try to fix. But because we consider this as a short-term issue, management comes as second priority. So we try to utilize the resources at the edge as much as we can. Now, this is a building material that we use for the edge and the core. For the core side, we have the big open rack that comes. This is they use OCP servers. So we can add more racks there, because in the central side, we expect most of the traffic. The NSA, for example, solution of the SA slices will be in the central side. But at the edge, we just try to minimize the services and the VMs that we are going to use there. So that's why we should have a different approach that need less power, for example, and be more compact for the footprint, etc. So that's why we offer there the Open Edge solution, the Open Edge 19, that is airframe Nokia's hardware. So we see here that we have one, the Open Edge chassis with the 3 rack units, where there we can have 5 servers with a 192 gigabyte RAM. And this is a dimensioning that we can see here, that we have 5 servers, and we can achieve with this 200 vCPUs, around 700 gigabyte RAM and 2.7 terabyte storage. This is based on a Ceph with a replication factor of 2. And then here we see the requirements from Ericsson MetaSwitch. So this can be covered with just those 5 nodes that they can run as compute nodes, storage, and controllers. We also have resilience there because we can have 3 different OpenStack controllers. So we saw here that it's a very good and compact solution for the edge side. Now for the VNF placement, and because of the different isolation, we have different zones. So we have the services zone, where we have specific hardware deployed there, where all the main VNFs will go there. Then we have the management zone, where we deploy mainly the MAN or the orchestration layer. So we have CBAM, CBND, we have the Ericsson VNFM and the Flow One, a service orchestration, plus the key side components that we use for testing. For the services zone, because as we say, it's a very small, we just have 5 servers, we just use only the services zone. And also we achieve isolation through different tenants. So whenever they need to deploy a different VNF or service, then the different suppliers, they can create their own tenant and then deploy their services, their resources in that specific tenant. So even if they come from the same vendor, they may have different tenants for those. Like MME and the SPGW, they come from Ericsson, but they use different tenants. And this is a solution that we see even from most of the vendors, because they have even different teams that they handle those VNFs. And then regarding the security, we have very strict policies coming from Nokia side. I discussed in the previous demo about some zones that, but here we see the real case that we have mainly 4 zones. One is for management, exposed, non-exposed, and secured. So when we design a service and the VNF, how it will be distributed, we have to decide, Telnero will give us as input under which zone we go. So as we see here in the exposed, we have the MME and the SPGW. In non-exposed, we have the HSS. So whenever we need to talk from MME and HSS, we need to go through the firewall. VNFs under the same zone, like MME talks to SPGW, can talk directly. They don't need to go through the firewall. So this is a policy that we need to apply for all of them. And then this is about the orchestration. Already explained the details in the previous presentation with all the steps, but this is a high-level view. So where the user deploys the slice, then gives the service requirements to NVO, and then NVO will try to orchestrate the whole slice, even if we have 2 different sites, the edge and the central side. So using the same orchestration, level, we can distribute it into sites. Now for the demo here, we have two different demos. The first one is about the already deployed defense slice, but at the central side because the edge is not yet ready. So we have the defense part already done, so one can quickly show the resources in each one. And then we can try to deploy one Ericsson VNF using the CBND. So we can see how we have the services there, we have the catalog, and then how from there we can push the different input parameters and deploy the VNF. So let me go quickly to show in CBND what we have. So this is a catalog, for example, that we have. So here we have all the NS packages that we need to deploy. So based on this, we can go to use and then say that I want to deploy one network service. And then here is all the network service that we have already deployed. So this is the SPDW that we use for the defense. So if we go inside that, we see that it's already deployed. And then here we see the VNFM that we use. It's the Ericsson VNFM. And as I said, the most important here is the input parameter. So we use exactly the same NS package, but we pass different input parameters so we can create a specific instance for that service. So this is all the input parameters that we need. Usually it's about network services, VM resources, and other parameters that the VNFD may need. And then of course we create and then we deploy the service. And then also in the NUADs here, we can see here, I talked before about the different security zones. So this is mapped to enterprises in NUADS SDN. So we can see here we have the exposed, non-exposed, management, and secured. So if we go inside, we will see all the networks that they have, for example, in the exposed side. So mainly, as we discussed, is about MME and the SPDW. So if we go to MME, we will see here all these networks that have been already defined. So before we deploy a service, as we say, we create the networks automatically, and then we deploy the resources. And then, of course, in the horizon, we can see here the different tenants. So from here, we can choose, as you see in the list, the different tenants. Then we can go to the tenants, in this case, MME. And then we can see all the resources that they have been deployed. So the last part here, all of this MME N4 is coming from the defense slide. So we can see all the networks that they have there and the VMs. And of course, here in the networks, we will see the networks that have been created automatically during the deployment, all the external networks, the layer 3 networks that we have created in the SDN WADs, plus the internal networks that the VNFDs have created. And now for the deployment, as I said, we are going to deploy one Ericsson VNF from NVO. So this will use the plugin that we have already developed. And then we will push the deployment of this plus creating the network and the Palo Alto configuration. So let's go first to the CBND catalog. So we can see here all the NSDs that we have. So we will use this NSD. So from here, we can create a service. We can give any unique name that we want. So MME demo 10, for example. It has to be a unique one. And then we can import the inputs. That's the most important thing. So we have predefined all the input parameters for this one. So if we want to deploy more instances, then we may need to use different JSON files. So here we push the JSON file. So here the first part is about the networks that we want to create in WADs. And the second part is what we will push to the VNFM. We can change here also the VNF name. And then we create the network service. So this is successful, and now we are going to deploy. So to deploy a service, we need to provide input parameters and then to say which component is going to use. The first thing is to decide about the SDN. We may have different SDN solutions. So in this case, we have the NUADs. And then here the tenant will be the MME since we deploy an MME VNF. Then we deploy it. And then we see that this start already to deploy the resources. It may take some time, but we may see quickly that this is running. I think we ran out of time, but let me show you the logs here. So we see that the creation finished successfully. Then now it's still running the deployment. So here we will have all the jobs. So whatever our NS is creating, we will see it here. So it started here with the network creation. So we see in the enterprise and the domain start creating all the nodes and networks. And then it will go to the VNF deployment. So totally this may take 20 minutes, but yeah, we cannot see it until the end, but it's just to show you how this is done from the different environments. I think we can stop it here and take some questions. Any question?
Any questions while it's running?
So as you see, more resources are deployed. So for the transport, yeah, the transport not yet, because this is handled by Telenor for now. So they have a fixed environment. So maybe Paul can talk.
Yeah.
But usually we orchestrate now whatever is inside the data center.
Yeah, no, the transport is manual for now. So setting up the VPNs in advance.
But if we need an API, this is also possible. I mean, during the orchestration, we can still go and set up the transport network. That would be also possible if we want
It's
to.
just a matter, really, another domain for us.
Okay,
It's just that.
coba end-to-end orchestration.
Yeah,
But
it's
Qualcomm.
Otherwise, nothing is the policy involved. Also predefined.
Yeah, for example, because this could consider as part of the infrastructure. So like the underlay is already there, we have already created some BGP policies in advance, even for the overlay. So it's already there. But also this can be dynamic. We can have another network service before we deploy all the services and the VNFs. So we can configure the BGP even once and automatically. So this is possible because we can see that the network service is kind of a recipe. So we can put there the steps. So we can create all of them automatically because we have the plugins, for example, if we have in the APIs, we can configure this, and then we go to the next step to deploy the VNFs in the network service.
We're meaning about the PCF, about the charging of the service itself, the policy and charging functions.
Not
No,
only
no.
charging, but also
The VPRN, for example, and the VPLS. So this is also possible.
and then the third one.
I think we are running a bit over time. So
Okay.
we have left on
Yeah, we can close it here.
There we go.
And then, yeah, we can see here that the VNF started deployed already. So we finished the networking, then VNF deployment is ongoing. So, okay, yeah, we can terminate it here. Thank you very much for the participation.